Hey everyone, thank you. Welcome to today's Angel Beat. Today we're going to be talking about DevSecOps and how you can really manage security while maintaining automation in a DevOps world. My name is Donovan Brady. I'm the Director of Solutions Architecture at Logicworks. And a little bit about the agenda. So we're going to be talking about the benefits that companies are going to achieve by migrating to the cloud, as well as what challenges they might face. And one of those challenges is usually security. So why is security hard? But also, how do we navigate those challenges? The answer is through DevSecOps. And so I'll take you through some of the benefits as well as some example environments and how you can actually do this, and plus a bonus round for a case study. Before we get into it, a little bit about Logicworks. Logicworks is a professional and managed services company specializing in migration, optimization, and managed services. We typically work with the hyper-compliant regulated customers that maintain HIPAA or PCI or high trust type of compliance, right? As you can see on the right-hand side, our customers are usually those software as a service mission critical applications that you use every day without even realizing it. Orion Health, the largest electronic health record company in the world, right? We are a premier AWS partner and an Azure Gold partner and expert MSP, and we are internally audited for PCI, HIPAA, High Trust, SOC 1, SOC 2, ISO 27001, and we do a lot of work with GDPR as well. So let's talk a little bit about the migration considerations. Why do customers look to migrate to the cloud? Well, first, they are looking to improve their reliability. You can leverage the global footprint of the public cloud, whether it's AWS or Azure or Google Cloud. It's probably going to be a lot more robust than just your individual data center or your two data centers that you might have deployed, right? Additionally, you look to increase your flexibility and agility, leveraging some of the automation tools that the cloud has to offer, ensuring that your developers have your resources up and deployed just in time. You don't have to worry about provisioning servers and making sure that you're not running out of space and hardware refreshes and things like that. Additionally, operational excellence, with better monitoring, detailed telemetry, automated incident response, and some additional serverless type technologies the cloud has to offer. You can benefit from a ton of automated processes in your operational journey in the cloud. And finally, security and compliance, right? A lot of people think that these are the same thing, but they are actually quite different. If you're leveraging the cloud, you can actually offload a lot of your responsibility and leverage the shared responsibility model to decrease the burden on your team to maintain a secure and compliant environment. But that's hard sometimes, right? Because two of these things were agility and flexibility and security, right? Security takes a lot of time to make sure that you're doing it properly, to make sure that every compliance check is actually checked, right? Everything is scanned and everything is deployed in the proper manner and mechanism, right? That does not usually go hand in hand with the idea of speed, right? But there is a silver bullet, and that is DevSecOps, right? That is leveraging automation to do your security work for you. Before we get into what DevSecOps is, I wanted to talk a little bit about why security is slow and hard in the cloud, right? Because a lot of people think that, oh, it's the cloud, it's just going to be secure by default, right? And then you hear about these breaches like the Capital One breach from a few years ago, and you're like, wait, I thought it was supposed to be automatically secure and compliant because AWS said that they're compliant. Well, there are some things that you need to do in order to make sure that it is going to maintain that compliance. And one of the analogies that I like to use when I talk about it is thinking about your data center and the cloud differently, right? If you think about your data center, it's really like a fortress. It's a fortress that you own the keys for, you've been building it for the entire lifetime of this fortress. You have had the final say in every single thing that goes into it, right? If you want cannons mounted at the top of it, if you wanted turrets, if you wanted a moat with alligators surrounding it, you could do that because it's yours and nobody can tell you no. It's private, it's locked down to only the people that have keys, probably you and no one else, you know. But in the cloud, it's very different. The cloud is much like a city. Think about New York. There are millions of people walking through these streets at all times every day. You're not going to prevent them from going anywhere. You're not going to stop them from looking around, from going to places, right? There's going to be crime, you know, because it's a large city, and that's what happens. But the question doesn't become, okay, well, so then should I not move to a city? Should I not move to the cloud? No, the question is, since this is different from what I've done so far, I need to think about it differently, and my operational practices become different as well, right? To reiterate, in your fortress, you have complete control. You manage all the resources. It's completely customizable. You can tailor it to your custom environments, right? In the data center, you can tailor your environment to suit your specific company's requirements, your specific compliance and security requirements, right? And finally, it's locked down unless provided access, right? Like a DMZ, for example. In the city or in the public cloud, everything is shared. It's a shared responsibility model. You leverage the cloud providers to maintain the security of the data center, the hardware, and their services, right? You're sharing the infrastructure and the architecture by default, right? Unless you pay additional for dedicated hardware, you're going to be on the same hardware as everybody else. There's also additional layers of connectivity. You know, you're going to need VPN connections or direct connects or things like that, just so that you can access your own infrastructure, right? And it's significantly larger, right? Like I just said about New York, it's got millions of people in it at all times. It's giant, you know, so that means that there's a greater attack surface. Like I said, there will be crime. There will be intrusion attempts, you know. And finally, you are subject to the limitations and requirements of the cloud. You can't just go and build a moat with alligators around your cloud. You know, you could do that in your fortress, but you can't do it in the city, because in the city there are rules and regulations, and only the governor and the mayor can tell you what is allowed in that specific city, right? So it's less customizable, but obviously AWS and Azure and the other public cloud providers really make it simple for you to customize as well. So like I said, is the question then, do I just stop here? No, it means you need to adjust how you approach this new city. You need to identify what the changes are, how you're going to change, and implement those changes, right? Typically with security, you're looking at the network protection, the host protection, right? So you're looking at your VPCs, your subnets, your VNets, right? As well as the hosts, the virtual machines, the instances, the EC2 instances, the databases, things like that. You're looking at identity and access management. How do I control people's access and authentication? How do I do this at scale and manage identity rather than user permissions, right? Monitoring and logging. How do I make sure that everything is going to be caught at the right time, and I can have a proper incident response protocol as a result? Patching, make sure my instances are up to date, right? Have the latest and greatest operating system that is secured and hardened against the latest vulnerabilities. And finally, reducing human error. We don't want to do any work manually, because manual work means an increase in potential for human error. We'll talk a little bit about how we can do all of those, but it's pretty hard and time intensive. That's a lot of stuff, right? But back to that silver bullet, DevSecOps. I'm very proud of this slide because I finally found a use case for Comic Sans font. It's perfect. Okay, so what is DevSecOps? Well, DevSecOps is a set of processes and technologies designed to improve the speed and effectiveness of security teams working in the cloud, right? It's not just the security teams, it's the engineers, it's your architects, it's basically anyone who has access to the environment who's going to be deploying or monitoring these resources, right? The be all end all, the case and point that you should take away from this is that security is possible at speed and scale. If you remember an earlier slide with the arrows that are going in two opposite directions, they don't have to diverge like that. They can converge as long as you automate, because as much work as has to happen, as you do that manually, it's going to equate to a lot more risk, right? So if you automate, you can make sure that these code deployments can be tested, they're linted, you do unit testing, integration testing, destructive testing, make sure that anything that goes into production is actually what you intended to go into production. And finally, you can enable automated guardrails to make sure that everything that gets deployed is going to follow your best practices. You don't have to worry about a rogue engineer deploying a resource that has configurations with your access keys or anything that can actually be disabled by default. The first way to do that is by building your compliant infrastructure via infrastructure as code templates, right? These are going to be your CloudFormation, your Terraform, tools like AWS Service Catalog, Azure ARM templates, that's Azure Resource Management templates, or Azure Blueprints, really whatever the automation tool is to templatize and manage your infrastructure as code, right? Next, you can leverage machine images, right? You can leverage things like Packery or the Amazon Machine Image Builder. And Logicworks actually has a proprietary one that we've been working on that leverages a couple of these different tools to create sys-hardened instances that can be rebaked with our customers' applications. It's a really neat solution because it allows you to implement those guardrails that I was just talking about, and you can deploy your application across however many customers, however many regions as necessary, right? And finally, configuration management, right? We all need to configure our operating systems to the lowest level. We need to make sure that they are, as I just mentioned, sys-hardened, the host is protected, we have intrusion detection and antivirus and anti-malware. And if I ever need to make a change and I log into the instance, then that would equate to manual work. So how do I do that with an automated tool? Well, you leverage tools like Puppet, Ansible, Salt, Chef, AWS Systems Manager, Azure Policy, Azure Log Analytics, tools like those, right? So if you build your infrastructure via infrastructure as code, you can ensure that everything is going to be deployed at scale with the expected and intended result. You're not going to have any snowflake resources. There are not going to be any outliers because every single thing that you deploy is going to be deployed from a template, right? The template won't change unless you change it. You can also prevent configuration drift by deploying some really neat tools called config rules, right? The first step to doing this is to deploy AWS config in all of your regions, centralize those logs, and so that you can export those to a third-party SIM like a Splunk, or even manage and monitor those within your AWS environment by something like Athena, for example, right? But then once config is enabled, you can actually set up managed rules and deploy conformance packs, right? As I mentioned, Logicworks works with a lot of HIPAA or PCI customers that have stringent rules and security requirements in their environment. AWS actually has conformance packs deployed by default within config that have a list of controls that you need to maintain for HIPAA or PCI compliance, for example, right? And as you deploy these tools, they are going to be a standard baseline of guardrails within the environment. So as you deploy, if you try to deploy something that does not actually match with what that guardrail expects, it will either prevent you from deploying that, or it will notify you that something was deployed outside of your intended guardrail, right? If that does happen, you can set up some automated configuration triggers to remediate that, right? So if somebody did deploy something, let's say there's an EBS volume that was deployed without encryption enabled, the automated trigger can go ahead and quarantine that and remove the EBS volume, or it can attach encryption to the EBS volume, right? All of these are leveraging automation to maintain compliance as code, or as some people call it, continual compliance. I mentioned a little bit about centralizing these config logs. There are a ton of logs that you have access to within your AWS environment, right? And I do want to make a point I've been talking a lot about AWS, but really this is a framework. It's a protocol for DevSecOps, just for ease of use and ease of conversation without having to name all the tools from all the cloud providers. I'm just speaking about AWS as an example, but this really is a framework that can be leveraged to deploy across any cloud provider as a best practice. So again, going back to the centralization of logs, so you have CloudTrail logs, which is your audit log within the environment, config logs, which are your deeper X-ray logs. It's like, okay, so CloudTrail told me who made a change and what was the change, but config is going to tell me what that change actually implied, what that meant on a greater scale, right? Then you have VPC flow logs. These are the connections into and out of your networks, right? And then you have console logs, you have application logs, system log, right? You have a ton of logs within the environment. There's no way for you to manually go through each of these in separate environments and separate buckets, right? The only way to manage these would be to centralize them and analyze them with an automated tool, right? If you leverage a tool like an AWS control tower, which for those of you who have come to other Angel Beats, or if you're going to be joining our Angel Beat later this afternoon, I often talk about how Control Tower allows you to automate the centralization of these logs and allows you to analyze them within the Control Tower or export them to a SIM, like I mentioned, like a Splunk or a Sumo Logic, right? It allows you to cross-reference all of these logs in the environment to ensure that, okay, like I said before, if I see that there was a breach or there was a large data egress from my S3 buckets, I can check my centralized log buckets to see, oh, that was actually Donovan exporting data from the AWS environment. And that was for this at this time into this other AWS account. And then you check all of it and you're all good, right? If it was malicious, if it wasn't it's such an optimistic outlook and it wasn't me, similarly, you can look and pinpoint where it came from, who did it, where it was going, and then lock that down and make the proper remediation in the environment, right? But you can't do that if you don't have these logs centralized or a mechanism to actually analyze them.
Hey, Donovan. Oh, good.
Hey, Ron.
We've got a few minutes left, so it's good to get a case study. I know there's a lot of gel information. The focus of this program is just in manufacturing supply chain, but I want to emphasize that these kind of capabilities are absolutely useful to ensure that you can deploy your cloud solutions effectively in that industry. And let's hear the case study now as we finish up. Logicworks does a lot of great things for many different clients that we've recommended to during Angel Beat.
Yes, absolutely. So I'll talk about a reference architecture here, which is at a high level, how we maintain the DevSecOps approach in our AWS environments. And then I'll talk specifically about how we did this for a customer called Stratasys. So if you look here, I know it's probably a little hard to see, but you can see that there are multiple different automation tools and security tools leveraged throughout the environment. At the top level here, we have a tool called Duo that we leverage for multi-factor authentication for any user access into the environment. From there, we leverage Okta, and Okta has two tools. We use the SSO tool, and we use the ASA tool, which is Advanced Server Access, right? That's going to give us a zero trust model for accessing our customer environments without having to manage, like I mentioned before, the individual user permissions. It actually allows us to manage the identities rather than individual users, right? Zero trust, centralized authentication, and authorization, right? Within each of these VPCs, you can see the instances themselves have these shields on them, and the shield represents that all of these automation tools are in place. We have Threat Stack, which is an automated real-time event monitoring and threat detection mechanism, right? Trend Micro deploys antivirus and anti-malware. Palo Alto, similarly, it handles our centralized egress and has additional security tools within there. And then, as I mentioned, those Okta ASA tools. Another tool that I would like to point out, speaking of Palo Alto, would be the Transit Gateway that allows us to centralize our egress through that Palo Alto to ensure all traffic is going to be inspected. Right? If we templatize all of these with an infrastructure as code tooling, like Terraform or Logicworks Image Factory, like I mentioned before, then you can ensure that every time you deploy one of these workloads, it's going to have all of these tools deployed by default. So you don't have to worry about, oh, I'm not moving as flexibly, flexibly, or as agilely as I'd like to, right? You know that it's going to be deployed by default, right? I'm going to skip this slide and I'll talk about the case study. So how did we do this in Stratasys' environment? So Stratasys is a global e-commerce platform and manufacturing company, right? They had business critical applications with a global footprint, right? They needed to be deployed in the US region, Europe, and Asian regions, right? And they were deploying an SAP implementation that was pretty legacy, and they didn't know how to move it all at once because it was attached to a ton of different backend applications, right? And the solution that we came up with was we actually replatformed their application into AWS, moved it over to AWS native tools, and designed a scalable landing zone that was governed by an immutable infrastructure pipeline. Pretty much everything that I'm talking about here, leveraging CI/CD and that Logicworks image factory, governed by CloudFormation and Puppet, to deploy and migrate the application data from the data center into AWS, right? As I mentioned, that SAP implementation was pretty complex. It had a ton of different backend dependencies to different applications. So we were able to remove those dependencies and isolate the individual applications and move them one by one, significantly speeding up their migration process and decreasing costs over time as well. Well, that's pretty much all I've got for you all today. Ron, I really appreciate the time. Thank you everyone for joining. My name is Donovan Brady, Director of Solutions Architecture at Logicworks. And if you're interested in working with us or doing a compliance assessment or looking to deploy workloads, optimize or migrate within AWS or Azure, feel free to give us a call. Thank you.